Jill Boyce. I'm with Nokia. I'm going to talk about the VSEI companion spec to VVC. And this is my first time at Demuxed, so it's an honor to get to speak at my first time here. All right. So I'm going to start with a little bit of background on what SEI messages are, because that's what VSEI is. It is a spec of SEI messages, so Supplemental Enhancement Information. And so these are messages that have been around since the time of H.263 with a common philosophy that's carried forward in multiple specifications since. And they contain metadata that is within a bit stream in a synchronized manner with pictures. And they're extra information, and they're addressed at specific use cases, and they're intended to be used to describe a bit stream or to give information that a receiver-decoder system might choose to act upon. But it does not affect normative decoder behavior. So video coding specs have normative decoder behavior where any conforming decoder must do have the same output as a reference decoder. But SEI messages don't fall under that category because they are optional. So encoders may optionally send them to address a specific use case. If they choose to use them, they have to use them as specified. They have to follow the syntax and semantics that are specified, but they don't have to use them. And then a decoding system, it's also optional whether or not it chooses to use them. It does not affect the decoder behavior conforming, but it can have recommended post-processing, which then the decoder is free to ignore or is able to do. However, application specifications from other groups, like ATSC, for example, might mandate the use of a specific message. And another important point is that the profiles that are defined in a video coding standard do not mention SEI messages at all because they do not affect the normative decoder behavior. All right, so now let me talk specifically about VVC standard. So prior to VVC, all SEI messages were defined inside of the same video coding specification, part of the main specification. But for VVC, the decision was made to separate most of the messages into a separate partner specification called VSEI. So why did we choose to do that? Why did the group that was defining these choose to do that? There was a few reasons. One of which is it allowed you to reference an SEI message by multiple different standards. Because before, like we would have a message that was defined in AVC/H.264 and then have to, copy and paste it again into the next spec and sometimes change a few words here and there and then copy and paste it to the next one, which was harder to maintain if you found a problem, just led to a lot more specification language. And so by putting it in a partner separate specification, it can be referred to not just by VVC, but HEVC, AVC, future standards as well. And so if another standard wants to use it, it has to assign it a payload type, and it has to reference VSEI spec for it. Sometimes some of the more complicated messages need a little wrapper because the referring specs have different terminology for similar concepts. And so it kind of makes it more generic. And so it's important to understand that SEI messages that are defined in new versions of VSEI can still be used in bit streams that were conforming to profiles defined in earlier versions of the spec. So an earlier, an HEVC main profile decoder can have these new SEI messages in it, and just older implementations can just ignore the SEI message, whereas newer implementations that understand that message can act upon them. Little just background about what JVET does. So the Joint Video Expert team that's developing these video coding standards. I've been a long-time active participant in these standards. VVC is the last major standard that was done, and it was the first version was done in 2020. And since then, the main work is exploration activity towards what's going to be the next generation standard. There's no timeline for it yet. It's still in exploration phase. But in addition to that, work continues on developing new SEI messages. So as new versions of VVC are released, new versions of VSEI are done in a time-aligned manner together. And so there's been 4 versions, and another version is planned to be coming. In addition, these groups are also responsible for maintaining earlier standards like HEVC and H.264. So there's a lot of SEI messages that are in VVC and VSEI. And I said most of them are in VSEI and only some of them are in VVC. I obviously don't have time to go through all of these at any length. I will mention just some of the use cases that they enable. So high dynamic range, scalability, multi-view, depth, alpha, film grain, 360 video, interlace, low delay. There's just so many use cases, and individual SEI messages address specific use cases. So these are the current versions of VSEI. But the main focus of my talk is what's coming, what's new, what are the newer advancements in this area. And so active development of SEI messages is underway, and there's kind of a two-tier system for managing it. So every time the JVET meets, there's a new output documents of the current status, and there's a two-tier system. So the kind of first tier is what was called in the working draft. And so SEI messages that are included in the working draft have been decided by the group that they're going to be in a new version of VSEI. It just has to work its way through the system to get to be finalized. But there's another category that's called the technologies under consideration, which is kind of like the lower tier, and it's of newer SEI messages that are still being studied and have to make some determination about whether or not they're mature enough or of interest enough that they should be in a new VSEI spec. So I'm going to talk a little bit about some of the SEI messages in each of these two categories of things that are upcoming. And there's still a lot of those, and I don't have time to go through all of them, but I've selected a subset that I think will be interesting to this audience. So here's the list, and as you can see, there's more in the category of the TUC than there are in terms of the working draft that have been decided to be moving forward. I'm going to start out talking about some of the ones in the working draft, and then I'll talk about some of the ones that are in the TUC. So in the working draft, neural network, post-filter characteristics SEI, and activation SEI. So this is actually two SEI messages that work together. And what it does is it allows the encoder end to give information to the decoder to do post-processing. And there's post-processing filtering using a neural network. And the neural network itself is not defined in VSEI. It's just that you have a way of communicating. You can actually signal a representation of it, or you can signal a link to where you can find the particular neural network that's used. But what the SEI message does, it indicates which type of operation can be done, and it can be more than one, and kind of a cascaded order of these operations. So you can have post-processing things like visual quality improvement, or chroma upsampling, picture resampling, colorization, temporal spatial extrapolation, or upsampling. And again, optional for the decoder to do, but if the decoder chooses to do it, it provides this information of the recommendation that the encoder has made for it. All right, next is the object masking information SEI message. Now, prior to this, there already exists an SEI message called annotated regions that allows you to do object tracking with a rectangular bounding box. But what this message adds is the ability to, on a per pixel basis, indicate object masks. And if you have the regular video, which is called the primary picture, in a multi-layer bit stream, you can choose to have an additional layer, an auxiliary layer, that has an object mask in it. And that's another picture that's coded using the video coding engine because it has individual pixels. And the SEI message basically provides information to say, all right, here's this layer that that is using the primary, and this is the object mask, and then how to interpret it. So in this example picture I'm showing, you can see the different colors corresponding to different objects. It provides information that says, okay, you interpret this color to mean this particular object, this other color to mean something else. And it's a flexible way to do that. All right, another SEI message is the encoder optimization information. And unlike the neural network post filter that I described, this also can describe some optimizations, but these are things that were done at the encoder prior to encoding. Whereas the neural network post filter is giving recommendations that the decoder might choose to do after decoding. So in this case, it's just providing this information of some of the things that the encoder has done. So what kind of optimizations it did, object-based optimization, temporal resampling, spatial resampling. So for example, if temporal resampling was done, it could help you know which were the pictures that were original pictures and which ones had been, created through an upsampling process. So if that information was useful for a receiving system to know. And so there's several categories that you can indicate as to what processing has been done. All right, next, the text descriptions SEI message. So this is a generic text representation that can be incorporated within the bitstream and associated with particular pictures. And it can provide information describing the pictures in text. And specific purposes have been defined that allow you to indicate what the purpose of it is. So there's a list of purposes that have been defined, and there are reserved fields so that additional choices in the future, it can be extended to have other different purposes. But for example, copyright information, you can indicate, there's a copyright, and because it's synchronized, it doesn't have to be saying, here's necessarily the copyright for the entire video, but you could identify specific ranges of, time within it for which the copyright applies. Or, AI marking, it's just an indication of what permissions could this be used for other purposes. And so it's extensible, and it also has a language indication, so you can include the text in a variety of different languages. Next one, okay, so all the ones I was just describing before are things that were inside of the working draft. But now I'm going to talk about some of the ones that are inside of the TUC, or the technologies under consideration. So the packed regions information. If you have an application where what you really care about is the region of interest rather than the entire picture, it allows you to efficiently code that. And so, like for example, you might have an application that you do a face identification, a face detection in one stage, and then later on you want to do a facial recognition and pick out the particular people. So once you've done the face detection, you can just extract those faces just themselves and then pack them into a smaller coded picture so you can save bitrate and resolution compared to if you had sent the whole picture, but it still lets you know these identified regions and then allows you, if you want to recreate a picture with them in those original positions where they had been. So the SEI message describes the number of regions and just where their sizes and locations are in the coded picture as well as in the target picture. Another is the constituent rectangles SEI message. So this is addressed at applications where you want to be sending multiple synchronized videos. A multi-view situation or a video plus alpha, video plus depth, for example. And now, of course, HEVC and VVC can already do those things, but they require the use of a multi-layer bitstream. So with, prior to this, you can have, a picture layer and a multi-view in a separate layer, another one, a depth in a different layer. But unfortunately, the most commonly deployed profiles of HEVC don't support the multi-layer profiles. So this is basically a trick to get around that, to say, I can actually composite a bunch of these pictures into a larger picture that is coded. And then the SEI message provides the information necessary to understand, where those other rectangles, they all have to be, the pictures that are composited here need to be rectangles, to indicate where they're located and then what type of information that they are carrying. And it's a very flexible signaling mechanism that the encoder can choose how it wants to arrange the rectangles in kind of any position it wants, although there is a restriction that they can't be overlapping. So every pixel position in the coded picture is only correspond to a single rectangle. But this, I have an example picture here of a multi-view use case with 3 views with the regular video plus the depth that could be then composited and coded with an existing HEVC codec implementation, but still allowing you to have this information in a standardized manner instead of just like an ad hoc manner that's very specific to a specific implementation. Next is the display overlays. Actually, this has some relation to something that Alex Gelati was talking about yesterday with overlays. So the display overlay information SEI message allows you to separately code the kind of a main picture and overlay pictures, and then provides the information that a decoder can use to generate the final intended display picture, which I'm calling a target picture, so that there can be multiple overlays that are applied in a specified order, and those overlays may have an alpha channel associated with them. And so there's just the process that's defined, and you can either code the pictures as separate layers, or you can make use of the constituent rectangle SEI that I just mentioned before to pack them inside multiple of these display overlays inside of the same picture. And so use cases include things like, logos, sports, and titles, and, product placement, replacing things. And it allows a much easier way if, like, for example, I want to have multiple different languages supported in an overlay. I don't have to, burn it into the video and code that entire video all of those different ways. I can just code the, main video once and do a really good job with it, and then have had these just the separate overlays. And by doing this, I'm also not required to have them be full screen. Like, I don't have to have just one background and one foreground. I can have more individual overlays that themselves are smaller. And so in this example that I'm showing here, the picture on the upper right is kind of the desired display picture where, some sporting scene, and I have a score that's semi-transparent, and then I have a, like in the bottom corner, some other logo. So the main picture is just coded as a regular picture, and then the overlays in this example, it's flexible, but in this example is chosen to take these 2 different overlays, the score and then this other logo, put them composited together and with their alphas all together, and because they're small, they can all get packed into a picture that's even much smaller than the original picture, so that there's not such a demand that otherwise if I had each of those and there's layers, I could have 5 layers and 5 times as much pixels to process, but I don't have to in this case. All right. I am running low on time, so I'll just really quick on this one. The bit depth ranges has to do with a way to cheat having higher bit depth content in profiles that can't support it by separating out low order bits and high order bits. And also one thing I want to mention, quality metrics. So encoder can know for specific pictures what the quality impact of encoding had been on the picture. And so if certain use cases, it might be helpful to have that information carried forward so that a decoder, for example, if you're an AI processing system, you might choose, I'm going to pick the highest quality frame that I'm going to do my, face detection, my facial recognition on, for example, or some other task. And it's flexible to define a lot of different types of quality metrics. So to summarize, this VSEI standard is in active development with new SEI messages that are coming, ones under study. And the messages that are defined can still be used with existing HEVC or AVC or VVC profiles, as well as new standards, because it doesn't directly affect the profiles. And these new SEI messages help VVC be more versatile. VVC is versatile video coding, and be more versatile so that it can address a lot of use cases without having to change the main codec, so that it's a general purpose codec that can be used for many things, but you can still customize it for specific use cases. And so I'd really like to get, audience feedback on if some of these SEI messages are interesting, and also a pitch for those that the services that re-encode and host videos generally are not carrying forward SEI messages, and it would be great if SEI messages that in the ingested content could also be carried forward for the ultimate streaming. Thanks. So that's it. Thank you.